In this presentation, we are going to discuss in detail what is meant by sequential testing. Sequential analysis or sequential hypothesis testing is a method of statistical inference where characteristic feature is that number of observations required by the procedure is not determined in advance. I have already explained this to you also, because at every stage either you are going to accept the hypothesis, reject the hypothesis, or you are going to continue the sampling procedure, and therefore the number of observations is not fixed. That means is not determined in advance. Depending upon the situation, the n is going to vary. That is, the sample size is not fixed in advance. Instead, data are evaluated as they are collected, and further sampling is stopped in accordance with the predefined stopping rule as soon as significant results are observed. So the rule will be decided in in advance. Predefined rule will be there when to stop the sampling procedure. सैम्पलिंग प्रोसीजर या टेस्टिंग स्टॉप करने का ही मतलब है आइदर यू आर गोइंग टू एक्सेप्ट द हाइपोथेसिस और वी आर गोइंग टू रिजेक्ट द हाइपोथेसिस, एंड दिस एक्सेप्टेंस एंड रिजेक्शन is done on the basis of this predefined stopping rule. Stopping का मतलब है either you are going to accept the hypothesis or reject the hypothesis, because in both the situation we are going to stop the sampling procedure, right? So instead the data instead in the sense sample size is not fixed in advance. Instead the data are evaluated as they are collected. We evaluate the data, we test it in accordance with the predefined stopping rule, and if that rule says that stop the sampling, accept the hypothesis, or stop the sampling, reject the hypothesis, then the further sampling is stopped. Otherwise, we will have to continue the sampling procedure. Now this is the merit that I was talking. Merit of sequential test procedure is that the sequential procedure can be constructed which requires on an average substantially smaller number of observations than equally reliable test procedure based on the predetermined number of observation. प्री-डिटरमाइंड नंबर ऑफ ऑब्जर्वेशन का ही मतलब है जो हम लोगों ने अभी तक रेगुलर जो टेस्टिंग पढ़ा हुआ है, टेस्टिंग ऑफ हाइपोथेसिस और एलआरटी ऑल्सो, जहाँ पे सैम्पल साइज इज फिक्स्ड. प्री-डिटरमाइंड नंबर ऑफ ऑब्जर्वेशन, दैट मीन्स सैम्पल साइज इज फिक्स्ड. सो इफ वी कंपेयर द प्री-डिटरमाइंड नंबर ऑफ ऑब्जर्वेशन जहाँ पे फिक्स होता है ऐसे टेस्ट को विद द सिक्वेंशियल टेस्टिंग, you will observe that the sequential test procedure can be constructed which requires on an average, मैं average की बात कर रहा हूँ, हाँ, on an average substantially smaller number of observations than equally reliable test procedure. So both the tests are equally reliable, but still you will find that the number of observations required in sequential testing, or average number of observation, I should say, average number of observations required in sequential testing are less than the number of observations required in our regular testing of hypothesis procedure. Thus, a conclusion may sometimes be reached at much earlier stage than would be possible with more classical hypothesis testing or estimation at consequently. Of course, because of that, because the number of observations we are requiring are less, we are reaching the conclusion at much earlier stage, and therefore we will naturally require lower cost और द एज आई सेड ह्यूमन कॉस्ट ऑल्सो, दैट मीन्स ह्यूमन रिसोर्सेज भी हम लोगों को कम लगेंगे इन सिक्वेंशियल टेस्टिंग. An essential feature of sequential analysis defined or developed by Abraham Wald is that number of observations required by the sequential test depends on outcome of the observation and hence is a random variable. मैंने अभी आप लोगों को बताया कि रैंडम सैंपल का जो साइज है वो फिक्स नहीं है. समटाइम्स सेम एक्सपेरिमेंट, सपोज आई एम डूइंग अ सेम एक्सपेरिमेंट, राइट, सेम हाइपोथेसिस को टेस्ट कर रहा हूँ, एवरीथिंग इज सेम, बट इन वन सिचुएशन यू मे रिक्वायर n equal to 5, in some situation you may require n equal to 4, or in some situation you may require n equal to 15. In other word, here the sample size or the number of observations I am talking about is a random variable. It is not predefined, right? So that is what the meaning of this sentence is, that number of observations required by the sequential test depends on outcome of the observation. It depends upon the rule that has been defined and hence is a random variable. The sequential method of testing the hypothesis H naught may be described as follows. So the sequential method, as I said, we are going to take 3 decision on the basis of a certain rule. So that has been described like this. A rule is given for making one of the following 3 decisions at any stage of the experiment. 3 डिसीजन मैंने ऑलरेडी आप लोगों को बताया कि कौन से वो 3 डिसीजन है. आइदर वी एक्सेप्ट द हाइपोथेसिस, और वी रिजेक्ट द हाइपोथेसिस, और वी कंटिन्यू द सैम्पलिंग इंस्पेक्शन बाय एडिंग एलिमेंट इन द सैम्पल. पहले अगर n इक्वल टू 1 है तो हम लोग बाद में सेकंड, इसमें अगर ये थर्ड डिसीजन होगा तो क्या होगा, n इक्वल टू 2 बन जाएगा. उसके बाद अगर फिर से थर्ड डिसीजन आ रहा है तो n इक्वल टू 3 हो जाएगा. सो वी एड 1 सैम्पल यूनिट इन द गिवन सैम्पल एंड कंटिन्यू दैट पर्टिकुलर इंस्पेक्शन टिल आइदर वी एक्सेप्ट द हाइपोथेसिस और वी रिजेक्ट द हाइपोथेसिस. ये पहले जो डिसीजन अगर हम लोग लेते हैं, फर्स्ट 2 डिसीजन, देन ओनली द सैम्पलिंग और इंस्पेक्शन विल बी स्टॉप. तब तक हम लोग कंटिन्यू करते रहेंगे बाय एडिंग एलिमेंट इन द सैम्पल. हेंस द प्रोसीजर इज कैरिड आउट सिक्वेंशियली, और इसीलिए इसको बोला जाता है सिक्वेंशियल टेस्टिंग. If decision 1 or 2, that means either we accept the hypothesis or reject the hypothesis, is made, process is terminated, process will be stopped. And if the decision third decision is made, we perform the next trial. Perform the next trial का मतलब है we add another unit in the sample and then make a decision based on the next set of observation. नेक्स्ट सेट ऑफ ऑब्जर्वेशन मतलब पहले अगर x1 x2 है तो x3 को ऐड किया जाएगा एंड देन वी विल अगेन टेस्ट द रूल ऑन द बेसिस ऑफ x1 x2 x3. तीनों ऑब्जर्वेशन को लेके हम लोग टेस्टिंग रूल को फिर से टेस्ट करेंगे एंड देन वी विल टेक अ डिसीजन डिपेंडिंग अपॉन द रिजल्ट ऑफ दैट टेस्टिंग. If decision 1 or 2 is made, process will be terminated, and if decision 3 is made, we perform the next trial again. तो ये चलता रहेगा. Thus, the number of observation n is a random variable. The value of n depends on the outcome of the experiment. So, if xm denotes the unit drawn up to mth draw. M indicates that we had drawn m units so far, right? So xm denotes the units drawn up to mth draw. So xm will be equal to x1 x2 up to xm. So this will be the sample at the after the mth draw. Clearly अगर हम लोग फर्स्ट यूनिट को ड्रॉ करके डिसीजन अगर ले रहे हैं देन इट विल बी x1, then x2 सुपरस्क्रिप्ट किया हुआ है x2 को, so on up to xm. Let mm denote the collection of all such xm, right? So different possible xm, the collection of such xm is nothing but mm. So just relate this with the sample space. Script x क्या था? Collection of all possible values of sample. This is nothing but that. mm denote the collection of all such xm. xm क्यों लिख रहा हूँ? क्योंकि this is the sample at the mth drop, right? So collection of all such sample is denoted by mm. That means this mm is nothing but our sample space. So if you remember, in testing of hypothesis, we either accept the hypothesis or reject the hypothesis depending upon whether your sample belongs to part 1 or part 2, which is nothing but the partition in the sample space. Similarly here also, mm will be divided into 3 parts, and this mm naturally is nothing but the m dimensional space. The rule for making one of the decision at any stage of the experiment can be described as follows. For each integral value m dimensional sample space mm can be divided into 3 mutually exclusive classes. वहाँ पे भी ऐसे ही था, यहाँ पे अभी हम लोग 3 म्यूचुअली एक्सक्लूसिव क्लासेस में डिवाइड कर रहे हैं. वहाँ पे 2 म्यूचुअली एक्सक्लूसिव क्लासेस थे क्योंकि वहाँ पे 2 ही डिसीजन थे, यहाँ 3 डिसीजन है. सपोज दोज क्लासेस आर rm dot rm1 and rm, such that if your sample belongs to rm dot, we accept the hypothesis h0. if your sample at the mth draw, इसलिए xm लिखा हुआ है, belongs to rm1, we reject the hypothesis h0. and if xm belongs to rm, we continue the sampling procedure by taking the additional point. additional point होगा तो वो कौन सा point हो जाएगा? m plus 1th point हो जाएगा. so by taking m plus 1th additional observation in the sample, thus sequential test is completely defined by the set rm dot rm1 and rm at the mth stage of the experiment. Since all the 3 sets are mutually exclusive, it is sufficient to define the 2 set rm dot and rm1, because rm then can be obtained using the complement of rm dot union rm1. So ये तीनों में से कोई भी 2 सेट डिफाइन किया तो भी चलता है, राइट? बिकॉज द थर्ड सेट इज द complement of union of the 2 remaining sets. So that is what I have written, because rm equal to rm dot union rm1 complement. That is, if the first unit is chosen, that means n is equal to 1, we have to consider one dimensional space, क्योंकि उस केस में m equal to 1 हो गया. So m1, अगर वो वन डायमेंशनल स्पेस है, then m1 will be divided into 3 subclasses, r1 dot, r11 and r1, 1 to indicate one dimensional space. After inspecting x1, depending upon the rule, we either accept the hypothesis, reject the hypothesis, or continue the sampling procedure. That means if x1 belongs to r1 dot, we accept the hypothesis. If x1 belongs to r11, we reject the hypothesis, and if x1 belongs to r1, we continue the inspection by adding element in the sample. So जैसे ही एलिमेंट ऐड हो जाएगा वो 2 डायमेंशनल स्पेस हो जाएगा, मतलब m1 के बदले मैं वहाँ पे लिखूंगा m2, and again this procedure will be repeated. The process is terminated only when either decision 1 or 2 is made. So this is basically the brief introduction about the sequential